Welcome to the first virtual lab. Today we're doing the reductive amination experiment. We're making an amine from these starting materials.
Dr. O'Reilly, that's a lot of arrows up there.
Who is that?
Hey, everybody.
Let's keep our 6 feet. But seriously, not a joke. A lot of arrows because this is a multi-step reaction, and a lot of reactions that people do to make important pharmaceuticals and other biologically active molecules take more than one step. So this is a 3-step synthesis where we go from an aldehyde and an amine, and we're making this amide, and we're putting the two pieces together.
So what's happening in that first step?
This first step, this nitrogen is adding to that position. There's a partial positive here, a partial minus there. This nitrogen is more electronegative than any of the other atoms, so it also has a partial minus. So its electron density is pulled to that position, and essentially that oxygen turns into the water that's given off in this process. So this right here, this intermediate, we'll call it intermediate 1, has this benzene ring, or phenol, form this imine.
Imine?
An imine is a carbon double bonded to a nitrogen. Thank you for asking.
Have we seen this chemistry yet?
We have not seen this chemistry yet in Organic 2 lecture, but we will see it in the near future. And what's kind of weird about this step? Did anyone read ahead and see how this one step differs from normal reactions we've done? Well, usually people don't, so that's the normal response. But this is a solid-solid reaction.
Oh, right.
So yeah, we're going to mix that solid with that solid. There's no solvent, there's no other additives. We're just mixing the two of them, and it's going to be pretty neat. We're going to start with the solid thing that we're stirring, and it's going to become a liquid, and then it will re-become a solid. It's going to be really neat. Wait on for that one. Then we have another arrow, sodium borohydride. We've seen this one before. It's kind of like an H-. We haven't really seen it in lecture yet, but we have seen it in the first lab when we were reducing a ketone to an alcohol. The H- is attracted to that position, so this is actually going to reduce this imine to an amine. That's where the reductive amination comes in. So essentially, intermediate 2, so this would be what is right here, intermediate 2, looks exactly like intermediate 1, but there's an extra hydrogen in that position. There was only one hydrogen here. Now there's a second hydrogen from the H-. The last step, we're reacting the amine with this acetic anhydride, and that is going to form our final amide product. So this is the third reaction condition. So it is what makes our final product. So that's what we're doing today. Yeah. Any questions?
Nope. We'll be showing you some video clips of the process as we go through it, giving you some data and some means of making observations for your notebook report.
And one thing that's a little bit, this is kind of setting us up for the labs in the future. This is the biggest molecule you've ever made. So analyzing it by proton and carbon NMR is going to be a little bit more complicated than what we've seen in the past as far as bromoalkanes and those types of things. And the final experiments in this sequence is a lot of kind of discovery or problem-based reactions where, again, you don't know what you're making. So this is kind of the most complicated thing that you'll make, that you know what you're making, and it's kind of getting you ready for those future experiments. So yeah, I think that's it. Yeah. Bye.